You're welcome to RHEMABOTICS. Our topic for today is proportion. So straight up, we're going to the format of the lesson, which is IPECA. So I stands for introduction, P stands for principle, E stands for example, C stands for class activity, and A stands for assignment. But before we start this lesson, I want us to pray. Father Lord, we thank you for this lesson we have today. We ask for divine understanding. Whoever that is listening to this lesson, watching this lesson, I pray that you open up this lesson, this topic to the person in the mighty name of Jesus. Amen. Okay, so straight up introduction, what is proportion? Proportion is the ratio of one quantity to another. It is an equation of two ratios. There are two types of proportion. Number one, direct proportion, and number two, inverse proportion. So we're going straight to the first type of proportion, which is direct proportion. In this type of proportion, one variable increases as the other variable increases also, and vice versa. That means as one variable decreases, the other decreases also. Okay, so principle. If y varies directly as x, what is y? Y is the dependent variable while x is the independent variable. So if y varies directly as x, that is y is equal to kx. So in place of the proportionality sign, there is equality and the proportionality constant. So in place of varies directly, you can see there is equality and the proportionality constant. So we move straight to the formula. So k, if you make k the subject of the formula, you divide both sides by x. So y will be divided by x. So if y should vary as x, and we have like two different numbers, which is y1 and y2. So as y1 varies directly as x1 and y2 varies directly as x2, this formula is telling us that y divided by x is equal to y1 divided by x1, and y2, and yes, the same equation is still equal to y2 divided by x2. You can see where this formula is derived from. It's derived from the original formula, which is y equal to kx. So if I make k the subject of the formula, you get y divided by x. So if k is equal to y divided by x, that means the same k is equal to y1 divided by x1, and it is also equal to y2 divided by x2. So let's move on to an example. The 10 shoes cost 5,000 naira. Find the cost of 3 shoes. Now you can see that as the number of shoes decreases, the cost will also decrease. So that's direct proportionality, because as one variable decreases, the other also decreases. So solution. In the question, you can see we have 10 shoes. So assuming we are taking our x1 to be 10 shoes, and the cost will be our y1, that's the first cost, will be our y1, which is 5,000 naira. Now they said we should find the cost of 3 shoes. Now you can see the value of shoes, the number of shoes has changed from 10 to 3. So that's our x2. x2 is 3 shoes, and y2 is unknown. So that we need to find a new value of y, or a new cost. So we go back to our formula for direct proportion, which is k equal to y over x equal to y1 over x1, which is equal to y2 over x2. So you can see y1 in our solution, y1 is 5,000, x1 is 3 shoes. Yes, so we have x1 is 10 shoes. So we have y1 5,000, that's y1 5,000, x1, which is 10 shoes. You can see over 10 equal to y2 is unknown as stated here, and the x2 is 3 shoes. Okay, so we have a ratio here, which is 5,000 over 10 equal to another ratio, y2 divided by 3. Please, the slash you're seeing here represents divided by. All the slashes you're seeing here will represent divided by. So you have 5,000 divided by 10 equal to y2 divided by 3. So we are going to cross multiply and make y the subject of our formula. So if we do that, the 3 we multiply with 5,000 and we divide everything by 10. So y2 will be equal to 5,000 times 3 divided by 10. So 5,000 times 3 gives us 15,000. So 15,000 divided by 10 gives us 1,500. Therefore, 3 shoes cost 1,500 naira. So that's that for direct proportion. Please, you can replay the video, pause, rewind for a better understanding as we move straight to the next type of proportion, which is inverse proportion. So you can see the class activity. Go to your progressive math, page 139, number 1. Solve number 1, number 2, number 3, number 4, and number 7. So that's your class activity. You can do your assignment, which is progressive math, page 139, number 5, 6, 8, page 140, number 12, and number 13. So we are moving straight to inverse proportion. Inverse proportion, straight up in this type of proportion, as one variable increases, the other decreases also. So that's why it's called inverse. It's indirect, as one variable, which is the independent variable, as it increases, it causes the dependent variable to decrease. So you can see from the first one is increasing while the other one is decreasing. So that is what we call inverse proportionality. So we move straight to the principle, which is if y varies inversely as x, that is y is equal to k divided by x. Now this formula originates from y varying inversely as x, which is y varying, using the proportionality sign, and you write 1 over x. So when the k comes in, when the proportionality sign changes to equality sign, k is brought in, and then you have y equal to k divided by x. Now I would like to write the formula preceding this particular formula. I'll do that quickly. That is y varies inversely as. Now the symbol we have here is called the proportionality sign. So let me use my spotlight again. So the symbol we have here is called the proportionality sign. So the moment you change the proportionality sign to equality sign, k comes in, and k is called the proportionality constant. So the moment you cross multiply, you get k equal to xy. Now the target is always the constant because the constant doesn't change. The variables, as the name implies, they change, but the constant does not change. It's constant. The value remains the same. So if you multiply the two variables, you always get a constant, irrespective of what they have. Yeah. So you can see k equal to xy, which is equal to x subscript 1, y subscript 1, which is equal to x2, x subscript 2, then y subscript 2. Now, this formula is $1 billion formula. Please don't play with this formula. Always work with it when you're solving inverse proportional or inverse proportion problems. It will really help you, and trust me, you won't regret it. So let's move straight to an example. Hope you've understood the principle, but I believe you get a clearer picture of it as we solve a problem. So let's go straight to an example. Okay. So in our example, we have let me read the example. Just give me a minute. Okay. Now in our example, we have four laborers can weed. Four laborers can weed a field in 9 days. How long will it take 6 laborers to do the same job working at the same rate? Now, as you can see, why there's a reason this particular question is an inverse proportion problem, because the number of laborers, if you increase the number of laborers, you find out that the time they will spend doing the same job will drastically reduce. So you can see from 4 laborers we have to what 6 laborers. So from 4 laborers it moves to there's an increase from 4 to 6 laborers. So the time 4 persons will spend weeding the field will be definitely higher than the time 6 persons will spend. So if you increase the number of laborers, then they will spend a lesser time. So you can see the inverse proportionality as one variable is increasing, the other variable, which is the time, is decreasing. So straight up to the solution using the, the beautiful formula which I introduced earlier, which is x1 plus k equal to x1 y1, which is equal to x2 y2. So what is our x1? X1 number of laborers, y1 is the number of days, that's the time, x2 the second number of laborers, and y2 give us the second time. Okay, so we are going to substitute all these values inside the main formula, which is the x1 y1 equal to x2 y2. So in place of x1 I'm going to put 4, which is this 4. In place of y1 I'm going to put 9. In place of x2 I'm going to put 6. In place of y2 I'm going to put question mark. But instead of putting question mark, I can still leave the y2 there so that I can make it the subject of the formula. And how do I do that? Is to divide both sides by 6. So 4 times 9 is 36. 36 divided by 6 will give me 6. So therefore, it will take 6 days. Sorry, not minutes. Yeah, 6 days. It takes 6 days. Let me do that correction quickly. It takes 6 days, not minutes, because the unit of the time in this question is days, not minutes. Okay, so that's that. So therefore, it will take 6 days for six laborers to do the same job at the same rate. So that's that. And please go through the video from the beginning, replay it as many times as you can. You can pause it, rewind, and all that for a better understanding. As I said, the formula is $1,000,000 formula. You can work with it anytime. It will give you the desired result, and you won't regret it. So see you next time on RHEMABOTICS. Thank you very much for watching. Please, you can subscribe, you can download, and you can also drop a comment. Thank you. Bye.